Hi, it's Liz Sneddon. Let's have a look at combinations and permutations. So the first thing we need to know is this idea about what a factorial is. So a factorial is talking about the product of an integer and the numbers below it. So for example, if I had 5 factorial, that's the same as 5 times 4 times 3 times 2 times 1. So it always goes down to the value of 1. And so this is one of the things that we use when we look at the different ways that we can combine things. We now have this thing called a multiplication principle, and it looks at how many different ways there are of filling different positions. So if I have 3 positions, so maybe I'm looking at a race and there are 3 different ways or 3 different positions when I look at my first, who comes second, and who comes third. And I know that there are P different ways of filling that position, Q different ways of filling the second position, and R different ways of filling the third position. Then when I multiply those together, that tells me how many different combinations there are. And this is important to know when we want to work out the probability of something happening. So there are 2 types. There's something called combinations and permutations. So when we talk about combinations, we are talking about whether or not the order matters. So with combinations, order does not matter. Whereas when we talk about permutations, order does matter. Okay, and what I mean by that is if I look at this, getting a red and then a blue, that is different from getting a blue and then a red in that first and second position. So with permutations, I'm going to count those as 2 different ways. Whereas under combinations, I'm just interested in the fact that I could get a red and a blue, and it doesn't matter what order they would be in. So that's what I mean by about order does or doesn't matter. So let's have a look at some examples. So when we talk about this one for you, talks about Jeremiah has 6 different shirts. He has 6 different shirts, 2 different ties, and 4 pairs of trousers. So how many different ways could he combine these together? So there are 6 times 2 times 4, and when I multiply that out, that tells me that there are 48 different ways that they could be combined together. So it could have shirt number 1, and then tie number 1, and then pair of trousers number 1. Or I could have shirt number 2, tie 1, trousers 4. Okay, so that's what we're looking for, is how many different ways that we could combine them together. This next question, 10 people are running a race. Okay, so we know we've got 10 people. And how many different ways can we order the first 3 places? Okay, so what we're looking at is we know we've got 3 positions, first, second, and third. So if that means in first place, I could have 10 different people in first place. Once I've allocated somebody to first place, I now have 9 people left. So there are 9 different people that could be allocated to second place. When I have somebody in first and second place, there are now 8 people left that could fit into third place. So this is where this idea of the multiplication principle and factorials comes in. So 10 times 9 times 8, that means there are 720 different ways that 10 people could be ordered in this race. If I want to look at the number of different license plate, so in New Zealand, typically a license plate would be A, B, C, 3 letters, and then 3 numbers, 1, 2, 3. So there are 6 different positions for us. So what we need to do is think about, well, what could we have? Well, we've got 3 letters to start with. Each letter, well, there are 26 letters in the alphabet. So I could have 26 different letters in that first position. I could have another 26 letters in the second position and up to another 26 letters in that third position. Then I've got digits, and so how many different digits are there? Well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 different digits. So then I could have 10 times 10 times 10. So those are the different ways that the different combinations I could combine 3 letters and 3 numbers into a number plate. When I multiply that out, that gives me 17,576,000 different ways that we could combine. So that's how many number plates New Zealand can issue when we've got 3 letters, 3 numbers. Then our last one, if we want to look at how many different ways can 4 people be arranged on a bench. So the first person sits on the left, the second person sits next to the first, and so on. So we've got 4 positions on the bench. So that means in the first position, there are 4 different people, and the first person is going to be arranged on the left-hand side. Then the next one will sit next. So once that first person's been allocated, there are now 3 ways, 3 different people that could sit here, 2 different ways people could sit there, and 1 different way there. So 4 times 3 times 2 times 1 means that there are 24 different ways that 4 people could be arranged on a bench. Thanks very much for watching.